Okay, I think we can start. So good morning to everyone and welcome to this webinar organized by MOREnergy Lab of Politecnico di Torino about MOST. MOST, Matlab for Offshore Floating Wind Turbine Simulation Tool, is a numerical model developed and by MOREnergy Lab of Politecnico di Torino. This webinar will be recorded and will be available on our website, as well as also the software that can be downloaded in the next few days from the website. The webinar is organized in three main parts. We will start with a short presentation about our research group made by Giovanni Bracco. Then Lorenzo Cottura and Riccardo Caradonna will introduce MOST and will show a short simulation about the tool. And finally, Massimo Sirigu will present the further development of MOST. And then we will have some time for questions and curiosity. So I will leave the floor to Giovanni Bracco that will make a presentation about our group.
Thank you very much, Alberto. Hello, everybody. So it's my pleasure today to give you a short introduction on who we are and what we do. So our name is Marine Offshore Renewable Energy Laboratory. We are a part of Politecnico di Torino Technical University. You can see a picture of our research group. And basically, in the years, you can see everything was started in 2006 with a particular focus on wave energy. And during, let's say, our 15 years activity, we try to develop as much as possible transversal competencies that can be used in the marine offshore renewable energy sectors. So mainly, as we will see, we started on wave energy and moving since 2013 on floating offshore wind energy. These are the two main activities nowadays, but actually starting quite quickly is the multi-objective energy platforms, basically meaning a multi-body framework for offshore renewable activities, and in collaboration with the other groups, also energy storages competencies. More in particular, well, there are some skills here you can see in the pictures. I would like to say control strategies for WEC, wind, and everything that moves. I can add because our background is in mechatronic engineering. A lot of tank testing and full-scale testing. We will see some picture, CFD, genetic algorithm, and everything that you may need for floating bodies into the sea. So everything started with the ISWEC wave energy converter. So it stands for inertial sea wave energy converter. It's a wave energy converter that uses a gyroscope to use the motion of a hull and convert it into an internal motion. So you transform the, let's say, 5 to 10 degree rocking motion of the hull into a 60-70 degree of oscillation. You can see on the video on the right, on the left, and that eventually will drive a generator that is controlled. By controlling both the generator and the flywheel speed, you can actually change the inertia and all the other radiation properties of the hull and harvest energy. One of the main key points is the reliability, because everything is enclosed inside a box. So here you can see a kind of our timeline of the, apart from modeling, also for the experimental tests. You can see the evolution on the hull and well, the evolution on the hull, maybe it's the easier to see. Then there was evolution on modeling and control. The first tests actually were carried at the curved wave tank in Edinburgh. And then we moved, improving both modeling, control, all the activities. And basically after 6 years of activity in 2012, we did the how can I say, average scale 1 to 8 test in the bigger wave tank of Rome, and in 2015 we put the first device in the sea. Since 2015 to nowadays, the ISWEC technology is under attention for Eni, that is the Italian oil and gas company, and actually this is our history. So I will close with the wave history with this picture on the ISWEC. After 10 years of development, the group was able to pass from the idea to the full-scale machine put in Pantelleria. Pantelleria is an island in Italy, and it's it has a very good potential for both wave and wind. Wind is a good potential because it's more than 40% of capacity factor. Wave is good in the scenario of the Mediterranean Sea. Is one of the most energetic sites. So going a bit back on the competencies, everything from resource assessment, modeling, design, cost analysis, validation, actually something we like a lot to do, and it's our normal operation together with experimental testing. So let's move a bit on the MOST side. So I will not give any spoiler on this. So just why use MOST, probably my colleagues will explain it later. Just a small anticipation, very user-friendly, flexible, parallelization, and good execution time. And apart from MOST, going to close, what we do also, we try to make up the RES platform, Renewable Energy Sources Platform. It's a platform that uses public database crossed together to analyze the potentiality from both wave and wind power in a certain marine area. So it's a platform we are building. Here you can see just some screenshots. And if you need any information, actually just write to us, and we will be very happy to actually to give any information. Closing on experimental test. Here you can see on the bottom left picture, it's our first I can say full-scale machine, even if it's not full-scale, because it's only a 3 kilowatt wind energy turbine, representative of a 5 megawatt put into the sea. This one was only put onto a lake, because the lake has a very good and predictable thermal wind, very small waves, and that is something we did in 2015 with this project, with a particular turbine that also was produced here in Italy with particular construction technique. It was a spar buoy put into the lake. We don't have a wave tank. Actually, we roam around Italy and especially Europe, also the USA, to do our experiments. We have only a static tank that you can see on the left, but in a couple of years, let's say 3 years, we will have our internal wave tank, also with the offshore wind capabilities. So I thank you very much for the attention, and I give the floor to my colleague for the MOST presentation.
Thank you, Giovanni. I change presentation. Hello, everybody. I'm Lorenzo Cottura, and with Riccardo Caradonna, I'm the creator of MOST, Matlab for Offshore Floating Wind Turbine Simulation Tool. MOST was created during our master thesis, during the work of our master thesis, and it's a tool to simulate the behavior of an offshore floating wind turbine in specific weather conditions and with different kinds of platform, wind turbine, and mooring. In this beta version, only the NREL 5 megawatt wind turbine, the spar buoy OC3, and the relative mooring will be available. But as said, we created script to create different concept of platform and wind turbine, different from the standard one. This script can be requested to this email, the MOREnergy Lab email. The theory behind MOST is the common Cummings equation that is the second dynamic law with the addition of the added mass, the convolutional integral that in this case is replaced by a state space model, the hydrostatic matrix, and then the laws relative to waves, drag, mooring, and wind turbine. So we have an overall of static and dynamics forces. And momentum, so we can call them loads. The other important theory behind MOST is the one for the wind turbine, that is the Blei element and momentum theory with the correction of plant tip loss, Glauert, and skew wake. This theory works starting from the mean wind at the hub coordinate. We detect the position of each node of each blade, and then TurbSim we found the wind in those positions. Then with the beam theory, we find the axial and tangential induction factor, from which we find finally the loads relative to the rotor. Then we apply a control logic on torque and on the blade pitch to obtain finally the wind turbine power and the reaction loss at the base of the wind turbine tower. Why we created MOST? MOST was born from our need to evaluate different kind of platform and wind turbine concepts, different from the standard one. We started with FAST, which is the reference simulation software for offshore floating wind turbine. But it was tricky for us to set different kind of platform with different characteristics. So we try to reproduce the results obtained with FAST, but a software more familiar with us. So we try to use Matlab-Simulink. Doing that, we create MOST, and doing that, we develop our internal know-how that is common in the entire MOREnergy Lab. We try to find a versatility for different kind of platform and turbine. That is the reason why we created MOST. And then we created also a model that is intuitive to be used also for the first user. This intuitivity can be seen also from the Simulink block diagram. As you can see, there are all the components on the that load the turbine, the wind turbine, that are wind, waves, mooring loads, and wind turbine base loads. The user interface for MOST is the one you can see in this picture. We will see later on a simulation run by Riccardo where he will set all the parameters and we will see all the potentiality of MOST. As said before, we can obtain their position and power as an output, as a result for MOST, but also a 3D visualization in real time of the motion of the wind turbine, as you can see in this brief video. Finally, we made a comparison between MOST and FAST to test our results. We aim to manage a root mean square error on position and output power lower than 2%. MOST is flexible and user-friendly. We managed to reach a very short time of simulation. We managed to make 20 minutes of simulation time in less than 1 minute. Our principal defect, the principal cons of MOST is the absence at the moment of the aeroelastic theory. This is a bibliography. You can find the first article, the mathematical model that is behind MOST. This article was written during our master thesis, developing MOST. And the other article show the results obtained using MOST that was used to do some analysis, and these analyses are exposed in those articles. So now I let the floor to Riccardo that will show us a simulation of using MOST. Okay.
Thank you, Lorenzo. Now I'm going to do a simulation to show how MOST works. MOST was created with the aim of allowing the user to interface with only one script. This script is called launchers and is in the MOST folder. This script is divided in 3 main sections. The first is used only after the first installation on the computer because it reallocates the directory. And the other 2 sections are the simulation sections. The first one is used to do a single simulation, while the last one is used to do multiple simulation in sequence. Now I'm going to uncomment this last section, and I'm going to click the Run MATLAB button. After my clicking, a user interface appears, and also this user interface is divided in 3 main sections. On the left, we have the simulation, the weather condition, both in direction and intensity of wave and wind. On the center, we have the simulation parameters and like the location of the wind turbine offshore or onshore. We can set the simulation time by the slicing bar or directly by insert the time in second on the box. And then we can choose the structure of the wind turbine. In this beta release, we have only the NREL 5 megawatt wind turbine, Spar OC3 and Moore OC3. And on the right, we have the control of the wind turbine and the real-time visualization. We have 2 options of the real-time visualization: the plots of position and power, and a 3D visualization of the displacement of the wind turbine. Then I click the Run button of the user interface, and after the compiling of the Simulink model, 3D visualization, as I can say, appears to show the movement of the wind turbine, and a real-time plots are shown with the main displacement, surge, rigid displacement, and rotation displacement, and the main characteristic of the generator, like generator speed, the generator power, and the control of blade pitch. The 3D visualization can be managed in speed of reproduction or of the viewer reproduction. And after the simulation runs out, the control user interface appears again for set a new simulation. If you want runs out the multiple simulation, you can just click the exit button, and as you can see, the MATLAB launcher is runs out also. During multiple simulation, only the last outputs are stored on workspace, but the all outputs simulation are stored in the results folder. And as you can see, the time requires to do a 20-minute simulation is only 49 seconds. Now I leave the floor to my colleague Massimo, who will explain the next steps of MOST and the future works. Thank you for your attention.
Hello, I'm Massimo, and I'm a PhD student in Turin, and I have a presentation about the developments of MOST in the last year. So I could yes, I will share with you my presentation. I want to expand. Okay. So new developments of MOST are the implementation of MOST in Simscape environment. So we can use WEXIM for the hydrodynamics. That is a library developed by Enrel and Sandia. The hydrodynamics is implemented with the lookup tables in which we can use the pre-calculated values of the force from the BMT theory. With Simscape, we can implement multi-body dynamics, and so we can implement a pendulum type platform, as you can see in the video on the right. We can introduce the wave and wind platforms, and we can introduce also ballast, in which you can control the level of seawater in the ballast. WEXIM is a library developed by Enrel, and it was used for WEC, but in our case we have used for the evaluation of the hydrodynamics of the platform. In WEXIM, the user can also use the nonlinear hydrodynamics starting from the STL file. With MOST, we can explore new concepts such as two turbines platforms, wave and wind platforms, and vertical offshore wind platforms. So these technologies can help reduce the LCOE associated to floating offshore technologies. With regard to the wave and wind platforms, so we have introduced the WEX on the platform, as you can see in the video. That is an artistic representation of the platform. So the advantages of these platforms are the increase of energy production with the same footprint of the farm. You can dump the oscillation of the tower, and so reduce the damage of the tower. And you can also prevent the variability of wave and wind, so you can have an output of the power that is more stable. So in this example, in this paper, we have developed a Nautilus 10 megawatt platform with a reduction of the LCOE of 10%, and we have improved the stability of the platform with regard of the pitch motion and acceleration of the nacelle. MOST is also used with optimization for the platform. So we have published 2 papers about the Sparboy and the Exaflot. MOST in this case is integrated with 3D CAD software that is Salome, that we have used for the evaluation of for the creation of the 3D CAD model that is then implemented in NIVO for the evaluation of the hydrodynamic properties. In this case, for the Exaflot, the results of the optimization are the cost of the platform with regard to the raw material, so the concrete and steel of the platform. In the future, the ideas are to implement the formability of the blades and introduce the fatigue analysis, so the stress analysis of the blade with Sonata, that is an NREL open source software. And the implementation of OVC, that is a WEC, that we can implement on the substructure, substructure, and finally we can implement the mean drift and second order waves in the hydrodynamics. I finished the presentation. Thank you.